He graduated from Heritage Hills High School. He has a job at PPG, so he's all ready to go here after he leaves USI. And this past semester, he's been working hard on a design for a transmission casing for the former planetary gear system on the USI Baja SAE vehicle. So Nick.
Hello everyone, my name is Nick Schwenk, and thank you for attending my senior design presentation on the transmission casing for the planetary gear system on the Baja SAE vehicle. My senior design objective is to design a new transmission casing for our previously developed planetary gear system on our Baja SAE off-road vehicle. What is a Baja SAE vehicle? It is an off-road vehicle that will survive the severe punishment of the rough terrain. The first video to the left shows one of our older 2012 Baja SAE vehicles traveling on our USI test track. The pictures to the right show our current Baja SAE vehicle. This Baja SAE vehicle is used to compete in the Society of Automotive Engineers International Baja SAE competition. It is an intercollegiate engineering design competition where students function as a team to design, engineer, and build and compete a vehicle within the limits of the rules. The next competition is in Auburn, Alabama in April 2015. A few of the events for the competition include suspension and traction, a hill climb event. But the video to the right shows an acceleration event. And also, it includes a maneuverability and an endurance race. This slide shows our Baja SA vehicle and a few of its components. First is the frame. Next is the wheels. Then the drivetrain and the suspension. Within the drivetrain, there are a few other components, which include the engine, which provides input power to the drivetrain, a CVT, or a continuously variable transmission, that provides varying gear ratios to the drivetrain. Next is the transmission, which provides a gear reduction and a forward and reverse mechanisms of shifting. And finally is the differential, which transmits torque to the drive axles. You may ask, why do we need a casing? A casing is used to house all of the transmission components as well encapsulate lubrication. Also, what is the difference between a CVT and a planetary gear system? A CVT, or a continuously variable transmission, is an automatic transmission that has variable ratios dependent on the vehicle's speed, engine RPM, and load. The planetary gear system is used for reducing these shaft speeds from the CVT, and it produces a constant ratio of gearing to the differential. And once again, my senior design objective is to design a new transmission casing for our previously developed planetary gear system for our Baja SAE off-road vehicle. This picture shows our current transmission and casing on our Baja vehicle. It is from a 1990s Polaris Explorer ATV. This transmission has a high, low, and reverse gear mechanisms. During competition, students would only use the high and reverse gear mechanisms, and the low gear mechanisms are not needed. They add an extra weight to the vehicle and extra space that is not needed for the transmission. The transmission casing design had to follow a few requirements. First was the casing size. The casing design had an overall length of 10 inches or less. The casing diameter had to be within 10 inches or less. The casing weight should be 13.5 pounds or less. For the lubrication, the casing design had to be self-lubricating. And finally, for the casing design strength, we wanted to design the casing to have a factor of safety of 2 or higher. When designing the transmission casing, 2 different sides of the planetary gear system had to be encapsulated. First was the input side. This side includes the forward gear mechanisms and the reverse gear mechanisms, as well as the clutch assembly. On the output side holds 2 other radial bearings. The transmission casing design is to have an upper and a lower portion of the casing. This slide shows, the first picture to the left shows my preliminary casing design. The advantage of this design was that it was an easy design. Some disadvantages with it was that it had a large volume, and it also had a large size. As well, it was heavy, and it had no lubricating system. The picture to the right shows the casing redesign. And this included advantages of having compactness, being lightweight, having a small volume, and it had a lubricating system. And one disadvantage with it, it was a complex design. This slide shows the different components of the transmission casings. In the middle is the planetary gear system. On the output side is the output side upper half, followed by the output side lower half. For the input side is the input side lower half, followed by the input side upper half. And 2 subcomponents of the input side upper half are the dipstick and the clutch selector switch. When designing the transmission casing, the planetary gear system had a few different interfaces that had to be incorporated with the design. On the input side, there were 3 radial bearing slots, an input seal, a drain plug hole, a stationary ring gear slot, an angular contact bearing, an additional radial bearing slot, and finally an output seal. The stationary ring gear is mated into the output side of the transmission casing. As you can see with this quick video, the ring gear is simply inserted into the output half. When it's mated, it is bolted together with 7 fasteners. The input side upper half has to interface with the clutch assembly, which these components are the clutch selector switch and the clutch assembly. The transmission casing had interfaces of a upper and lower portion, and these portions are bolted together with 10 exterior bolt hole locations. The input side and the output side are bolted together with 6 different bolt hole locations. The transmission casing assembly has mounting interfaces that are located on the input side lower portion. It consists of 2 mounting rails that have 6 different bolt hole locations. The transmission casing is to be self-lubricating. Some of the components, as I stated before, are on the input side upper half. And this includes the dipstick and the dipstick hole. To add lubricating oils to it, you add oil to the dipstick hole and you fill it to the oil fill line. To replace this fluid, there is a drain plug hole. The transmission casing will be made of aluminum alloy 6061 with an average wall thickness of 1/4 inch. The table in the middle shows a few of the material properties of aluminum alloy 6061. We chose this material because it provides a lightweight but yet relatively strong design, as well as it has great corrosion resistance and toughness. It has great machinability and weldability for the machine shop. And it is one of the most inexpensive and available alloys within the industry. The transmission casing has a few concepts of operation. First, for the lubricating system, it will use synthetic gear oil by Royal Purple. Next, the fasteners shall be 1/4 inch SAE grade 5 nuts and bolts. For these nuts and bolts, we will use Loctite blue thread locker. And finally, a new concept will be to, once we install these fasteners, to take the bolt head, paint a line over it, and while the vehicle will be in a competition event, students can notice if the bolt will be losing torque if the bolt turns, and you can see a mismatch within the painted line. After the design, the transmission casing had an overall weight on the input side of around 5.6 pounds. The output side has around 5.4 pounds. This brings a total of just under 11 pounds. Next is the overall casing dimensions. The overall length ended up being around 9.6 inches. The diameter ended up being 9.5 inches. Next, the transmission casing was used with SolidWorks for FEA analysis to determine a factor of safety. A factor of safety is a structural capacity of a system beyond its expected loads and actual loads. And once again, our desired factor of safety should be at least 2. This first image shows the input side of the casing. It is simulated with 135 pounds force on the exterior bearing location. This determined that the factor of safety was to be over 200. Similar results on the output side ended up still having a factor of safety of over 200. This slide shows our cost analysis for the senior design project. This includes materials to be purchased, contracted labor through Lively Machine Company, and a theoretical student and faculty labor, with the contract labor still being requested. The total thus far is $6,221.96. I'd like to acknowledge Dr. Natasha Smith, my faculty advisor, Dr. Glenn Kessel, and our USI Secretary, Donna Moore. And this final slide shows the transmission casing design all coming together in a quick animation. Thank you. Does anyone have any questions?
Questions?
Nick, does that tie in with the variable speed belt drive system, or is that an entirely new drive itself?
Are you talking about with the CVT?
Yeah, yeah.
I mean, it just gets the input power from it, and it just makes it into one gear ratio.
Okay.
So,
What was your overall savings in weight on the redesign?
my first requirement was to be within 13.5 pounds or less, and the weight reduction with this new design ended up being just under 11 pounds. So just a few pound reduction.
Nick?
I've got a couple quick questions.
Okay.
Where did you find those requirements, and how did you determine the applied load that you were using in your FEA analysis?
To answer that question, I used some of the previously calculated shaft design calculations. I used those from previous student design reports, and I used that within my simulation. And for the requirements of the length and the size, it was stated before that the size needed to be within a volume of 10 inches by 10 inches by 10 inches to fit within the drivetrain configuration.
Any other questions? Okay, Nick, you had an animation of, at the end of the whole assembly going together.
Right.
Is that how you intend to assemble the case?
Yes. Let me play it for you again. I wanted to make it into 4 separate pieces because the hardest part was mounting the stationary ring gear in the center. I don't know, it would be very difficult with having just an upper and a lower portion to install the stationary ring gear. A possible casing redesign could be incorporating the ring gear in the actual casing itself.
Okay, thank you. Any other questions?
Actually, do you mind? How does aluminum do? You analyze the factor safety, so from a strengths perspective, it looks fine. How does aluminum do in fatigue?
That is a great question. With looking at an SN curve for fatigue analysis, with a cyclic loading for this transmission casing at 10 to the 6 cycles, it would require around 200 megapascals of stress for the casing material to fail. And within this FEA analysis, the highest amount of stress that acts upon the casing is around 1.3 megapascals. So we're way under that fatigue stress.
Excellent. Thank you.
All right, is that it? All right, let's give him a hand.